Hello everyone, welcome in this factor analysis lecture series. Today I will discuss how to conduct factor analysis, the various steps involved in conducting factor analysis. However, before proceeding to the procedural steps of the factor analysis, I would again like to reiterate the meaning of the factor analysis. What is factor analysis? You all know that factor analysis is a technique, or rather a set of techniques, statistical techniques that are used to examine the intercorrelationship among a set of variables and to identify, after examining their interrelationship, the subset of variables in such a way that one subset of variable is low correlated with the other subset, but the variables within each sets are mutually highly correlated with each other. And I have given several examples in my earlier lectures. You can go and see that how we identify these, but those examples were basically based on some geometrical representations or some simple examples giving correlation matrix. Actual factor analysis involves a lot of mathematical calculations, matrix algebra. However, I will not discuss those mathematical details because my focus of lecture is to the applied users of factor analysis. Therefore, how we can do factor analysis with the help of different softwares. Though in this particular lecture, I am not going to cover any statistical software per se. I will basically discuss the theoretical steps that are involved in factor analysis. So the next slide will show you the steps of the factor analysis, and these steps can be divided into several steps. These several steps of the factor analysis can be broadly classified into two classes. One, you can say the preparation phase, preparing the data for doing factor analysis, and the other steps are the actual factor analytic steps. So the present slide shows you the eight broader steps of doing factor analysis. The first one is problem formulation and design. I will explain each of them one by one. Then the second step is when we have designed our research for factor analysis, then the second step is collecting the data and checking the appropriateness of the data matrix. That involves three major decisions: the sample size, the composition of the data matrix, and whether the measures, the variables that we have included in our factor analytic studies, they are highly dependent on each other or independent. They should generally be independent from this. I will discuss the detail. And then when we have collected the data and checked the appropriateness of the data matrix, then the next step is constructing correlation matrix, because for most of the factor analytic techniques, not for all, some uses some other matrices also, but for most of the factor analytic techniques, correlation matrix is the main input to do further analysis. So construction of correlation matrix is the next step, and in this I will discuss two things. One, what measures of association and relationship should be used, because correlation or product moment correlation is one method. There are other methods also I will discuss. And then when we have created the correlation matrix, whether the correlation matrix is really appropriate for doing factor analysis or not, then we should check the significance and other aspects of the correlation matrix. You can say the appropriateness of correlation matrix. If the correlation matrix is appropriate, then we will proceed to the actual factor analysis, that is how to uh, conduct factor analysis. Then the first step. So step one, two, three, we can say the pre-processing stage. So we are not actually doing factor analysis. From step four and onwards, our real factor analysis journey begins. So the first thing for doing factor analysis is to decide which method of factor analysis has to be used. As I am saying in my all lectures that factor analysis is not one technique, it is a set of statistical techniques. So there are different methods of doing factor analysis like principal access, principal component, maximum likelihood factor analysis, and many others. So first we will have to decide for our purpose, for our research design, which factor analysis technique is suitable. When we have decided the factor analysis technique, then how many factors, because the purpose of the factor analysis is to reduce the dimensions, they reduce the data set into fewer subsets. So we will not extract as many factors as there are variables, because the purpose of the factor analysis is to reduce the data set. So how many factors, this is one big question, and there are a lot of discussions going on how to determine the number of factors, but some methods have been evolved that I will discuss how to determine how many factors to extract and retain in our factor analysis. And then when we extract the factors using the specified factor method at step 4, the resultant factor is called unrotated factor matrix, and that unrotated factor matrix is a raw factor matrix which will pose lot of difficulty in interpretation. It is very difficult to interpret, and therefore for simplifying the factor structure, another step is involved, that is called rotation of factors. So there are different methods of rotation. What is rotation? What are the methods? I will also discuss in this lecture. And then when we have selected the factor analytic method, determined how many factors to extract, extracted those many factors, then rotated those factors. Then the final step is to interpret the factors. And very simply interpreting the factors here, I would say, is to identify the name, the construct underlying the clustering of the variables. For example, in my previous lecture, I gave example that we analyzed 4 variables and found that 2 variables, vocabulary and comprehension, they are highly correlated, and on the other hand, picture completion and picture assembly, they are highly correlated. There are 2 subset of variables, 2 factors in the 4 set of variables, and then we named these 2 factors as verbal intelligence, explaining the relationship between vocabulary and comprehension, and performance intelligence, explaining the relationship between picture completion and picture assembly. So, interpretation of factors involves factor naming, but it is not limited to only that. I will discuss this in detail. And finally, there is one more step we can follow to validate the factor structure, because what factor structure we have is obtained in one single study may not generalize across the universe or the population. So validation of the factor structure is also needed. So I will cover these steps one by one. And then in the next lecture, I will show you how to do this using some statistical software. I will begin with the SPSS, and then I will show you these steps of doing factor analysis using some open source and free softwares, because SPSS is very costly and commercial software. But This is most widely used software. Therefore, I would also like to discuss in next lecture how to do factor analysis using SPSS. So let us begin with the first step, problem formulation and design. Like any research, the factor analytic research also starts with formulation of the research question and the research design. So we should must clearly state our objectives of the factor analysis. For what we are going to do this factor analytic research. Here I will give my own research example that has been published. The paper has been published in Project Journal of Projective Psychology and Mental Health. You can visit my personal web page and you can read this paper. Eh, We were interested in knowing that the happiness or the well-being, the subjective well-being, from where it comes. It is coming from our own achievements, satisfactions, the individual achievements, or whether this happiness is shared happiness. It is, I feel very happy. When you ask, how are you feeling, sir? How are you? I say, I am well and fine. And then when I say I am well and fine, I see that my family is well and fine. My son is well and fine. So if my wellness is dependent on my family's happiness, happiness of my sons and daughters, my friends, my relatives, my neighborhood, then this type of happiness may be called shared happiness. So based on this logic, and this is the step theory behind the hypothesis. So we defined the objective of the research to examine the independent and interdependent sources of well-being, whether the well-being comes from our own independent achievements and independent qualities, or it is interdependent or dependent on others, also the others who are close to us. And then the theory behind this hypothesis must also be stated. And for this particular example, the theory was that the people from individualistic culture, they largely focus on their own achievements and aspirations, and people from collectivistic culture like India and Asian countries, people focus more on shared happiness. They feel more happy when their other close relatives are also happy. They may feel not that much happy if some of their relatives are not happy or not achieving much. So, with this objective, we started the research. And the theory was that the interdependent and independent self construal, we perceive ourselves as psychologically independent or interdependent based on the individualistic and collectivistic cultural mandates. And remember that these both tendencies may coexist. So, within individualistic culture, people may have both these tendencies, the independent self construal as well as the interdependent self construal. So, in formulating the factor analytic research, the objective must be stated, theory behind those objectives must be included, and generally, I have skipped these 2 points. Now, I will come to this, that generally the purpose of the factor analytic research may be either of the two types, data summarization or data reduction. There is very thin line to differentiate between these two, but some researchers, for example, when you go to the book of Hare, the multivariate statistics, he make distinctions between these two. Some others also make distinction between these two, data summarization and data reduction. So when the purpose is data summarization, it means we are largely interested in how various variables within our set of variables that we are going to study, they are interrelated with each other. We do several analysis and then we try to understand the relationship and underlying latent variables. The data reduction is also knowing the latent variables and the dimension. We also do the same thing, but here the purpose is to understand understand those dimensions and to identify which variables or which items form those dimensions. So this is some differences between these two. So these may be, so our purpose of the factor analysis may be data summarization or data reduction. I would recommend that go and read two different books to better understand this, because I have to cover the whole steps of doing factor analysis, so I am not discussing much here. So in brief, we have to formulate our research design. The objectives should be made clear. The theory behind those hypotheses must be given there. And then, after determining the objectives and the theory underlying those objectives, then we will have to select the variables or the measures for our study. They should be selected based on the objective and hypothesis and decide the measurement levels. Generally, the metric scale continuous measures are preferred in factor analysis, but other metric level data can also be factor analyzed using different other techniques. Even if you are having nominal ordinal data, some methods are there to arrive at results very similar to factor analysis, though we cannot say factor analysis. So, when we have designed the factor analytic research and collected the data or going to collect the data, then we should check the appropriateness of the data matrix. So, for factor analysis, the first and most important thing is the sample size. Larger the sample, better is the result. But when I am saying larger, you will be thinking how much large. 100 would be called large or 500 would be called large. And there is no one simple answer that I am going to suggest to, and there is no simple answer in the literature. For example, Comrie suggested that if you are doing factor analysis on 100 people's 100 participants, it is a very poor sample, not good for factor analysis. If you are doing on 200, it is fair, 300 is good, 500 is very good, and 1000 excellent. But these suggestions do not include how many variables. Suppose you are going to factor analyze 900 variables and having a sample of 1000. I do not think that 1000 sample size is very good. But suppose you are having only 10 variables and doing factor analysis, then 1000 definitely excellent. So some researcher says that these simple guidelines are not very good because they do not take into account the number of variables being analyzed or studied in the factor analysis. So another widely used rule of thumb for determining the sample size, which includes the number of variables also, says that at least 10 or 5 participants or subjects at a minimum for each variable should be taken. So suppose we are having 10 variables or 10 items in our questionnaire, we want to do factor analysis, then according to this rule, minimum 50 to 100 participants should be there. Cass and Teenley, they advocated the use of 5 to 10 subjects per item, but up to a total of 300 respondents. So, suppose you are having 10 variables, then according to this rule, if you are going for 10 participants per variable, you will say that 100 is okay. But Cass and Teenley, they are saying this rule should be followed, but the minimum respondent should be 300. And above 300, according to them, the relationship of items to number of subjects become less crucial. But these are some of the suggestions given by the researcher. I would not say that this one is correct or that one is correct. And in the next slide, Costello and Osborne, they have published one paper, Best Practices in Factor Analysis. You can search the internet and luckily you may find this paper. They did a survey of 2 years studies done on factor analysis, and they arrive at the results that I am showing in this slide. They noted that around 14% of the studies, 15% of the studies, they used for two participants for one variable. And this is around one sixth. Surprisingly, very low number of variables were used. But around 63%, if you go by the cumulative percentage, then around 63% of the studies they used a minimum of 10 participants per variable or less. But if you go by the individual percentages, you will find that there is no such criteria which we can say is most prevalent. The maximum percentage is from 5 participants per variable to, and the minimum is 2 participants per variable. And around 26% researchers use this criteria. So really it is very difficult. So I will say that larger the sample, better is the result. And some studies and some researchers suggest that sample size is not that much important if the data is strong. And strong data in factor analysis means if the commonalities are very high, like zero point 0.8, and the variables are not cross-loading. So getting such strong data is also very rare. So the suggestion would be to sample as many participants as possible and try to have more participants per variable. There is no rule, but 300, 400 sample size for say 10, 20, 50 variables will be okay. Now, how to collect the data? Suppose you are working on a questionnaire having 50 items, and if you collect the data on say 100 participants, and for quickness of data collection you split the questionnaire into two halves and you administer 25 questions on 50 participants and the other 25 questions on the other 50%, then these sub-matrices of the data cannot be combined for factor analysis. So data matrix should not be composed of sub-matrices from different data sources. If we have to do factor analysis, all the variables must be measured from the same group of participants. All the items should be administered to the same group of participants, to one group of participants, not to the sub-matrices. And these are some points that I will discuss in next, that when the correlation actually I will discuss, then I will discuss this, that correlation should be this. And the variables should be somewhat normal, no outliers should be there, no variables uncorrelated with any other, a few are permitted, so not more than 10 to 15% near zero correlation should be there. If there are too many near zero correlations, then data cannot be factor analyzed. And similarly, no variables should be perfectly correlated. If they are perfectly correlated, they are just duplicate variables. So the correlation must be somewhere in between 0 and 1. A few near zero correlations are permitted, like 10%, but most of the correlations should be lower than 1. So multicollinearity is also a problem, not only in multiple regression but factor analysis also, and when I will discuss dependence of measure, that point will come. So if there are some variables having perfect correlation or near perfect correlation, then it would be appropriate to remove one of the variables from the pair of correlated variables. So sample size is okay, the data composition is okay. Then the measures that we have taken should be independent. There must not be dependency. Independence of the measures is another requirement that should be ensured before doing factor analysis. If there is any dependence, suppose two or three variables are dependent on each other, then this dependency may artificially increase their correlationship, and we may arrive at a factor which is basically an artifact of this dependence and not the real factor. So how dependency occur? It can occur in several ways. Dependency can occur when you are using, say, a scale and their subscales also. So the total score will be the sum of the subscales, and if you are putting the composite score as well as the subscale score, then there will be a correlation between composite and subscales. So this type of score should be avoided in factor analysis. Either include the component score or the composite score, not both, because it will introduce dependency in the measures. Another type of dependency occurs when scores from the scales that have items in common are factor analyzed. I have given one example here. For example, there is a scale, thinking introversion scale. This has 43 items, and another practical orientation scale is having 30 items. And both of these scales share 8 items. 8 items are common. If you will analyze these two scales simultaneously, then the 8 items from the first scale and the second scale, they will cluster together. Why they will cluster together? Because the 16 items are forming a factor? No, because they are duplicate items. There is a dependency. So such dependency, and it is not, if the meaning is similar, they are having almost similar content, they not should be literally equal. If their psychological content is same, almost same, then it may introduce dependency. And finally, dependency also occurs when scales are abscissative in nature. That is, low score on one scale forces the scores to be higher on the other scale. Just I will give one example, and the scale can be of different type, normative, abscissative, and so many. Abscissative scale, for example, you are putting, suppose measuring the three qualities, say X, Y, Z within a person, and rather than asking one different items on 5-point scale, you are putting three items for each of the traits X, Y, and Z. If I take X, then Y and Z will be zero for me. So there is a dependency. Such type of scales are called abscissative scale, and they also introduce dependency. So the data should be on a larger sample. There must not be any dependency in the measures. Then our data is appropriate for factor analysis. Now we have obtained the data. Then we have to create the correlation matrix, and this will be the basic input for factor analysis. So most often the correlation coefficients are used. These are the most commonly used measures of association. However, under some conditions, the correlation coefficient underestimates the relationship. If the relationship is curvilinear, correlation coefficient will not estimate, particularly when the variables are dichotomized, then the correlations may be underestimate of the actual relationship. Similarly, if There is severe skewness because of dichotomization of the variables that will limit the magnitude of the correlations also. Despite this, the correlation and the correlation matrix is the most important. The product moment correlation or similar correlation coefficient depending on the nature of the data are the most commonly used measures of association. However, there are other measures of association that can be used. Here I would like to say that when you are having scores of an individual on two or more variables, then the scores basically represent the profile of that individual. And the profile is defined in terms of three things: the level, the dispersion. The level means the mean of the scores on each variables. Your mean may be high on one and low on the other. The dispersion, the variations between the mean scores. And the third is say, the rank order of the variables. So you may be high on first three and low on the last three, like this. So the correlation coefficients, they assess only one aspect of the profile, that is the say. Uh, the other two aspects, the level and dispersions, they are not assessed. So other alternative measures of association have been suggested, like distance measures, cross product indices. These two measures, they are sensitive to all the three indices or indicators of the profile, that is level, dispersion and say. And covariance is sensitive to two, the dispersion and say. But despite all these things, the correlation matrix in real practice is the most commonly used. Now, suppose we have computed the correlation matrix, we have created the correlation matrix, then the next step is to check whether the correlation matrix is appropriate for factor analysis. And there are different statistical testing to be done to ensure that our correlation matrix is appropriate for factor analysis. One such test is Bartlett's test of sphericity. This test is used to test the hypothesis that the variables are uncorrelated in the population. That is, population correlation matrix is identity matrix. This is the null hypothesis which is being tested by the Bartlett. If this test is not rejected, then factor analysis is not appropriate. Why? Because the null hypothesis is that the population correlation matrix is identity. That is, there is no correlation among the variables. And when the variables are not correlated, then we cannot do factor analysis. Remember the assumption that a set of intercorrelated variables. If variables are not interrelated with each other, then it cannot be factor analyzed. So, Bartlett's test of sphericity should be significant. Another measure is called MSA, the measure of sampling adequacy. And Kaiser-Meyer-Oaklin MSA is generally calculated, which ranges from 0 to 1. If this KMO value is less than zero point 0.5, then generally the correlation matrix is not considered good for factor analysis. So, larger the KMO value, better is the correlation matrix for factor analysis. And here is a guideline. If it is between zero point 0.5 to zero point 0.7, then it is a mediocre type of correlation matrix. 0.7 to 0.8 good, 0.8 to 0.9 great, 0.9 and never marvelous. So, KMO measures of sampling adequacy should be higher than zero point 0.5 for the correlation matrix to be factor analyzed. If the KMO measure of sampling adequacy is small, then the correlations between pairs of variables cannot be explained by other variables. and factor analysis may not be appropriate. Another is anti-image correlation matrix. This anti-image correlation matrix, here I would like to explain the term the image of a correlation matrix and anti-image of a correlation matrix. When you create a correlation matrix based on the predicted variables, each variable in the data set is predicted by the remaining variables using multiple regression. And when you create a correlation matrix of those predicted variables, then that correlation matrix will be called image correlation matrix. And the correlation matrix of the unpredicted part will be its anti-image correlation matrix. So in SPSS, when you are going to do, or in other software, this statistical principle is not required. There you will do and you will get an output anti-image correlation matrix, and you have to go to the diagonal values of the anti-image correlation matrix. And like KMO, if all values are 0.5 or higher, then the correlation matrix is appropriate. So the Bartlett's test of sphericity rules out the possibility that variables are not having zero correlation. But how to rule out the possibility that variables are highly correlated having multicollinearity? So for testing this multicollinearity, we can determine the determinant of the matrix, and if that determinant is greater than 0.00001, then we can do factor analysis, because this suggests that the issue of multicollinearity is not that much severe to preclude or not to do factor analysis. So up to this, we have learned how to prepare our data, what to see in our data to do for the factor analysis. Now, the real factor analysis, when data is appropriate, correlation matrix is appropriate, then we have to begin the real journey of doing factor analysis. And the first question will come to our mind, that if there are different methods of doing factor analysis, which method will be appropriate for our study? So let us have a brief classification of various methods of factor analysis. And this classification is being taken from Tinsley and Tinsley 1987. I thankfully acknowledge this has been adopted from this paper. This is one article published on how to do factor analysis. According to these authors, the factor analysis may be either descriptive or inferential. And similarly, factor analysis may be either exploratory or confirmatory. In descriptive factor analysis, the aim is not to generalize the obtained factor structure or the findings either to the population of participants or to the population of variable. The basic purpose is to describe the structure of the variables, the factor structure, and therefore for generalizing the findings of the descriptive factor analysis, the factor analytic study must be replicated on other samples. Until and unless it is replicated again and again and the same factor structure is not obtained, we cannot generalize. On the other hand, inferential factor analytic methods, they provide the opportunity to make generalization for either the population of the participants or the population of the variables, but not for both together. I will discuss all these methods, then I will say which can be used for generalizing for the population of variables and which can be used for generalizing population of the participants. Similarly, factor analysis can be of two types, exploratory and confirmatory. If we are not having earlier knowledge how many factors, how many dimensions will be there in our questionnaire or in our data set, then the factor analytic technique that are suitable for this exploration is called exploratory factor analysis. On the other hand, we have earlier knowledge that this questionnaire, like Eisen's personality questionnaire, measures three domains: extraversion, introversion, one domain, neuroticism, other, and psychoticism, the third one. Then, whether in our sample, whether in our Indian adaptation, Asian adaptation, or any other language adaptation, the same factors are coming or not when we are having this objective, then we will follow a method of factor analysis that will try to confirm whether the earlier obtained factor structure is present or not. So, this is a type of hypothesis testing or testing the theory, and these methods are called confirmatory factor analysis. So there are now four cells based on this 2 by 2 classification. So some of these statistical techniques of factor analysis are basically exploratory and descriptive factor analysis. Principal component I have already discussed in my previous lecture, but here I would briefly explain each of them in one or two sentences. Principal component analysis, some researchers say that this is not factor analysis, but some researchers they classify it into factor analysis. It analyzes the total variance, not the common variance. So the commonality estimate for this principal component analysis is generally taken as 1. Whereas principal factor analysis, it is also called principal axis factor analysis, is similar to principal component analysis in some way, but it is a technique which aims to analyze the common variance, and therefore commonality estimates are never kept as 1. If we will keep commonality estimate as 1, then this principal factor analysis will give the same result as principal component analysis. For principal axis factor analysis, generally the squared multiple correlation is taken as the commonality, initial commonality estimate, and then the factor analysis is done. After extracting the factors, the real commonalities are calculated as I have discussed in my previous lecture, and then those commonalities are used for doing factor analysis, and this process is repeated again and again. This is called iteration. And when the findings converge, when the commonality estimates converge, and there is a predefined conversion criteria, then factor analysis is stopped. And generally, such conversions require 3, 4, 5, but a maximum of 25 to 50 iterations are generally permitted. Another descriptive exploratory factor analysis is called image analysis. This is basically a variant of principal axis factor analysis, but rather than analyzing the correlation matrix, here the image matrix is analyzed, and I have just explained that image matrix is a correlation matrix of the predicted variables. So the correlation matrix is rescaled in such a way to produce image matrix, and then that image matrix is analyzed. It is also called image covariance analysis. And minimum residual analysis is given by Herman in 1976. This is another technique And all these four techniques, they do not assume either the variables as universe or the participants and universe. They, sorry, as sample. They consider that the participant that we are studying consists the universe and the variables that has been studied consist the universe. So inference cannot be drawn because they do not consider either variable or the participants used as uh, sample. So minimum residual analysis is another technique. Now coming to the exploratory but inferential. So canonical factor analysis, Raw's canonical factor analysis, it is also called, and maximum likelihood analysis. Both of them assume that the participants are sample of the universe and the variables are not sample, they are the universe itself. And both of them utilizes the canonical factor analysis, also utilizes the method of maximum likelihood, but the canonical factor analysis is a method which is generally preferred when we are interested in individual differences in terms of factor scores. So canonical factor analysis maximizes the canonical correlation between the set of variables and the factors obtained. And the maximum likelihood, and both of these methods, the beauty is that both of these methods do not require any communality estimate. And the third one, the third inferential factor analysis is alpha factor analysis. And this factor analysis yields factors which maximizes the alpha convex alpha reliability of the factors. Now coming to confirmatory factor analysis, so multi-group factor analysis, confirmatory maximum likelihood factor analysis, and literal is called basically linear structural relationship. This is given by Joris Cog, and literal is also a software. So they are basically all the confirmatory factor analysis. Now we can say that they are based on structural equation modeling approach, and then there are different variations in structural modeling approach, and so there are variations in the methods too. So for this lecture, I am stopping here, and in the next lecture, I will start the other part of the methods, that is how to proceed further when we have decided. So let me summarize here. Today we have discussed that for doing factor analysis, some preparation is required. First thing is that our design, our research questions should be clarified. This will tell what method to use, what variables to choose, what metric levels should be used. When the design of the study has been completed, then we start collecting data and then we check the appropriateness of the data matrix. The sample size should be adequate. The data should not be coming from sub-matrices, and the measures that we have used should not have dependency, and I have given several examples. So when the data matrix is appropriate and data has been collected, then we will go to compute correlation matrix. There are different measures, correlation coefficient, distance measures, and others, but generally we use correlation coefficients. And when correlation matrix is ready, then we check the appropriateness of the correlation matrix. The correlation should not be all near zero, and the correlation should also not be near one. So if the correlations are almost perfect or very highly correlated, that will pose the problem of multicollinearity. So we test the correlation matrix. If multi-correlative will be present, then the value of the determinant will not be higher than 0.00001. But if the value of the determinant is higher than 0.00001, then that suggests that the issue of multi-polarity is not there. And Bartlett's test of sphericity tells us that the if it is significant, then the null hypothesis is rejected, that the variables are having zero correlation. This is the null hypothesis is rejected. And another criteria is the MSA, measures of sampling adequacy, and KMO is used. If KMO is greater than 0.50, it is good. Higher the value of KMO, better the findings. And the anti-image correlation matrix should not have diagonal values less than 0.50. When correlation matrix is okay, then we have to decide whether we have to do descriptive factor analysis, whether we have to do inferential factor analysis, and in this, whether we have to do exploratory factor analysis or confirmatory factor analysis. So the next lecture will be focused on doing exploratory factor analysis. So we will be focusing only on these methods and how to decide which method is best. Rather than ending here, I would go to the next slide and then it will be better. So choosing a factor analytic method. So there are two main approaches that are generally used. So most widely used are either many of the researchers use principal component analysis, though many of the statisticians do not classify it as a factor analysis, but in name of factor analysis, if you will survey the research literature, you will find that majority of researchers follow principal component analysis. One probable reason is that this is the SPSS default. So those who are very new, they may be going with the default version, and therefore they might be reporting principal component. But the other reason for doing principal component analysis is the computational simplicity. Principal component is computationally simple, and it assumes that all variance is common variance. So this is slightly implausible assumption. All variance cannot be common variance. There must be some specific and some error variances. But this is the most commonly used. So when comes to choosing the method of factor analysis, one option is principal component and another is principal axis factor analysis or principal factor analysis. And the difference between these two methods is the difference in estimating commonalities. In principal component, as I have said earlier, that commonality estimate is used as 1, and in principal factor analysis, the commonality estimate is generally used as a squared multiple correlation. The correlation of one variable, the multiple correlation of one variable, the given variable with the remaining variable, and that correlation, that multiple correlation is squared and used as commonality estimate. And the first factor extraction is done. Then the actual commonalities based on the extracted factors are computed and they are used as the next commonality estimates, and the process goes on till the findings converge in n number of iterations. So here I will stop today, and then in the next lecture I will cover the other steps. If we have extracted the factors, then what next has to be done. Thank you very much. Seeing you very soon in the next lecture.